located in the center of South America, next to Brazil, Argentina, Chile, Peru, and Paraguay. Bolivia has 1 million of square kilometers, and we are 10 million of people. Bolivia is the poorest country in South America and the second poorest after Haiti. However, Bolivia is rich in natural resources, has a big biodiversity. We have forests, petroleum, gas, minerals, lake, salt springs, and big river, and also interesting mountains. As you can see, in the Amazonic region, we have a nice biodiversity and a lot of animals, some alligators. We have the dolphin, river dolphin, that is different to the dolphin on the sea, jaguars, and the big rivers. But sometimes the access to this place are a little dangerous. The altitude here is very low. We have areas with around 100 meters above the sea level to 700 meters above the sea level. Also, we have in Bolivia the valleys. They are around 2,500 meters above the sea level, and it is the place where are growing the different kind of food, especially cereals and different fruits. Also, the coca, the emblematic coca is growing here, but in Bolivia we are using the coca just for as a medicine, coca tea for the stomach and sometimes for the headache and the headache related with the altitude. In the altiplanic region we have the big mountains. One of them is the Illimani mountain that is possible to see from La Paz. La Paz is the principal city of Bolivia. The peak of the Illimani mountain is at 6,200 meters above the sea level. And also in this region we have an interesting fauna as llamas, vicuñas, and albahacas also. In this region we have the Titicaca Lake. The Titicaca Lake is the highest lake in the world, and it is very big. It has 8,000 square kilometers, and it is at 3,800 meters above the sea level. From here you can see a very nice view, and it is very close to La Paz. If you go to Bolivia, it's one of the first places to go to know. So all those nice natural resources are threatened by permanent degradation process. So very many of the natural resources are degraded for the different human activities, the different anthropogenic activities. One of them is the mining and metallurgic activities. So now I will give you a Bolivian mining background. Here you can see the Bolivian culture and time. We have in Bolivia the Tiahuanaco culture. The Tiahuanaco culture comes from 2000 before Christ to 1100 after Christ. So as you can see, it's a very long civilization, and its culture disappeared suddenly. Nobody knows exactly how. And then comes the Inca civilization, but it is from 1,350 to 1,500, around 100 years, no more. And the Inca civilization, many people know, and many people go to, for example, to Peru, to Machu Picchu to know this culture. And then comes the colonial period, and then the Republic. So Tiahuanaco was the first civilization in the Americas to mine and use minerals. Here we can see the Sun Temple. The Tiahuanacos displayed high levels of technology. They know exactly the mineral extraction, the metal craft, and also the foundries, especially with the copper, and the mineral development and different use. They were using some clamps made with copper for fix those blocks. As you can see here, the blocks are fixed very symmetric. They have a very symmetric constructions. It is also other temple, the Kalasasaya temple. And then the Spaniards, attracted by those treasures, arrived and violently conquered the Inca Empire, and then started the colonial period from 1540 to 1825. And they discovered different deposits of gold and silver, mainly in the Atlantic region. So over hundreds of years, they extracted a lot of gold and silver, and they sent to Europe millions of tons of gold and silver and other minerals as well. So today they were not taking care with the environment, and today the mineral extraction in the small mines mainly it's still doing, they are still using the traditional methods. So Bolivia was a major gold producer in the pre-Columbian times. We have in Bolivia the Gold Museum. I think in Colombia you have also the Gold Museum. And there is possible to see many objects made with gold and silver as well. For example, llama, some plates, or different objects made with gold. Also the monolith with gold incrustations and laminate tiara made with gold. Also this culture was doing different objects as disc bags, different containers, tools and weapons with silver and copper. They were using as well the mercury for paint the faces of the noble women. The tin iron and lead was used also for many different objects. So all those minerals were extracted by the Tiahuanacotas and Incas in La Paz, Oruro, Potosí. It is the Andean region. They had also, the Spaniards had the mita labor. So the mita labor was a system that was a forced labor they were forcing to the indigenous people between 18 to 25 years old to have a very hard work inside the mines for 12 hours by day, extracting the minerals. And they were extracting in the Potosí, in Cerro Rico, that means Mount Rich. This mountain was discovered during the colonial period, and the population here was around 150,000 inhabitants. This mountain is located in Potosí. Potosí was the famous city in South America and one of the biggest cities in the world, was very famous compared with Paris in that period. So then Bolivia was the major silver producer in the world. And it is the picture where the coins were made during the colonial period. So by the end of the 18th century, the decline of Potosí was quickly by the long struggle for the independence. The prices of the minerals were decreasing as well. and comes the beginning of the Republic in 1825. So in this period the mining was practically in ruins, but Bolivia was free. It is the place where the act of the independence of Bolivia after the war with the Spaniards was signed. The name is Casa de la Libertad, like a liberty house. So at the end of the 19th century, the silver mining was recovered and the tin mining began. In the 20th century, Bolivia became a major tin producer, and we have a high world demand, and the price increases again. So the discovery of the tin in some minerals, such as silver, was increasing the production. So in 1929, Bolivia was positioned as one of the world's major tin producers. But between 1940 to 1946, Bolivia it was during the Second World War. Bolivia was exporting to United States around 40,000 tons of tin, but the price that the United States paid was $0.41 per pound, when the real cost was $4.5 per pound. So we lost a lot of money and a lot of mineral then. And then in 1948, the world tin market collapses, and in 1986 started to increase the price again, and it was good again for Bolivia. And in 1980, in the same year, the metals traditionally extracted by private miners, but not only tin, but also other minerals. So after some years, the mining cooperative sector was the major gold and silver producer in Bolivia, especially in a mine named Coricollo. Now we still working with the different cooperative sector. This sector is getting more strong and stronger, but the problem is that they are not taking care with the environment, as we will see in the other slides. But no, Bolivia not only have mining activities in the Andean region. Bolivia has also mining activity in the Amazonic region. We have mainly gold, and the people is using mercury for the extraction. The process is very rudimentary, and they extract the mineral and bring to home, and inside the home put the mercury for extract the gold, and burn the mercury inside in a closed environment. So many people has problems of toxicity with the mercury in this region. And also in the mining in the oriental region of Bolivia is very important. This place has approximately of 75 square kilometers of mineral acid area. Here is a big deposit of iron. The estimation is between 40 to 42,000 tons of iron. So, coming back to the mining in the Andean region of Bolivia, I will explain you about the principal mines that are located in these regions. We have around 100 mines, and the principal minerals are lead, tin, silver, gold, iron, and some others. But the problem is, as I told you, many people also from the colonial period were not taking care with the environment. So some places in the Andean region close to the mines looks like this. So the Huenuni mine is the most important tin mine in Bolivia. It began silver production in the colonial times. The production is around 6,000 of tin by year. The minerals also have silver, zinc, lead, and iron. San Jose is other important mine. It is located very close to a city named Oruro. It is not working, it's not active now, but the acid drainage still going out, are not stopping. And many people is crossing for the acid drainage, even the children is going to the school, and the pH in that small rivers that in that acid drainage is around 0.9, so it's extremely dangerous. And Coricollo is one of the biggest mines in Bolivia. The mineral has especially gold and also silver. The production is around 40 tons by day. And the Bolivar mine was discovered in the early of the 19th century. It is the principal mines are tin and silver. So we have also some foundries. The foundries, this foundry treat around 20,000 tons by year. They have different steps for the foundry, but the problem is the emissions. They have strong problems sending to the environment sulfur oxide. It does not comply with the Bolivian regulation regarding the emissions. So we, at the university, we started to analyze the environment in this region. And this region is part of the TPPA system. Titicaca Lake, the Sagudero River, that is the river that comes from the Titicaca Lake and goes to Popo Lake, and then the Popo, and then comes the Salars. So the climate in this region is semi-arid and cold. We have two seasons, the dry season and the wet season. The dry season is from May to October, is in our winter, and the wet season is in our summer, from November to April, is the opposite in Japan. And here we can see some pictures about the seasonal variation in the Popo Lake. So during the rainy season, the Popo Lake has water and the rivers start to grow. But sometimes during the dry season, especially if the year is dry, the rivers disappear, and sometimes the lake also disappears. And now we can see a topographic cross-section of the TTPA system. The Titicaca is at 3,800 meters above the sea level, and then comes the Desaguadero River and the Popo Lake at 3,600. And the outlet of the Popo Lake is the La Cajahuira River, and then comes the Salars. So in this region, we have different types of contamination, as the organic and bacteriological contamination coming from the urban centers, also the mining contamination, because as you see, we had a lot of mines around there, extracting mainly lead, silver, iron, tin, gold, and others. But also we have a strong natural contamination for the presence of the different minerals with toxic contents at arsenic, lead, and some others. Other problem is the high salinity in this region. We have high concentrations increasing from north to the south. We have especially sodium chloride and sodium sulfates. So all those factors are to the people living there as victims of the contaminated environment, and also the hard work inside the mines, the arid climate, and the water resource degradation. So the environmental conditions are very complex. The life expectancy in this region is no more than 48 years. It is completely different than the life expectancy in the cities, where it is 71 years. So in the experimental part here, we were taking samples in all the river of the Popo Basin and also in the lakes. We were taking samples also in different wells, taking groundwater samples around the basin. We decided to take the samples in both seasons, the rainy season and the dry season, and we were taking samples for many years, so we have an interesting database of the results from 2001 to 2010, and we did the field work for taking surface water samples. We were taking in plastic bottles, and for the sediments also in plastic bags. And we were analyzing pH, conductivity, temperature, TDS as physicochemical parameters, and also some anions as sulfates, nitrates, phosphates, also alkalinity and chlorides, and the main cations as sodium, potassium, calcium, and magnesium, and toxic elements as cadmium, zinc, lead, arsenic, and iron. So we have the analysis of the surface water, groundwater, sediment, and plants. For the analysis, we use the ion chromatography, the atomic absorption spectrophotometry. Yesterday I was looking all the equipment that you have in the chemistry department, and you have a really wonderful equipment. So those equipments are new for us, but you are really lucky to be here studying this university. You have really wonderful equipment for all the analysis. And then also we were taking groundwater samples in different kinds of wells with pumps, with manual extraction, drilled wells, so different kinds of wells around the basin. We had samples of 90 wells. Also, we took the samples of biota, aquatic biota, in order to know the heavy metals concentrations. So, about the results in the environmental impact, we found two main areas in this region. This area is affected mainly for the mining and metallurgic activities, and the green one is not affected for the anthropogenic activities, but is affected by the natural contamination. So here in the region affected by the mining activities, we found very low pH and high sulfate concentration, and also very high heavy metals concentration. The other region has neutral pH, normal sulfate concentrations, and not so high heavy metals concentrations. But here the groundwater concentrations of arsenic are the highest in the region. So the principal points that we found were the Popo Lake that has the highest cadmium concentration, as the Pasnia River located in the same basin with the highest zinc concentrations. Also the lake has the highest lead concentration. Arsenic and iron are also very important, and this region has one of the highest arsenic concentration around the world. In the sediments concentrations also we found problems in the same places. The Popo River mainly, it is the Popo River where are located different mines, and also are thermal springs. This place has the highest heavy metal concentrations in sediment, and also the Wanumi River where is located the principal tin mine. In the south, the concentrations of heavy metals in sediments are much better, are lower, so it is not a big problem. We did a comparison also in surface water and sediment samples in the area with mining influence and the area without the mining influence. We can see especially the difference, the arsenic, iron, zinc, and cadmium in the area affected by the mining activity, and in the sediment, especially with the lead. So the seasonal variation is affecting a lot. As you can see, it is the north of the Popo Lake, and here are the different rivers. So all the rivers coming from the mines are going to the lake, and you can see the strong charge of sediment that go to the lake. And the first rains are reaching great quantities of soil products and are transporting contaminants in the mining regions that is increasing in the wet season. So the concentrations were changing also between the dry and the rainy season. The arsenic has the same behavior as the cadmium, is decreasing in the low during the wet season, but the lead is increasing during the wet season as a dissolution of the metal. And the behavior is similar compared with the chlorides and sulfates that are increasing as well during the wet season. So we did a correlation between the surface water, sediment, aquatic plants, and groundwater between the arsenic and the other heavy metals. So sometimes it was difficult to define why we found a reduction in the surface waters in a concentration of some element, and why we found an increase in the sediments. So in the area is a correlation between all those factors. Sometimes the sediments are accumulating the heavy metals or the aquatic plants. Also, the groundwater is very important, mainly with the arsenic. In the sediments, also the concentration of arsenic and sediments are different in the sediments, in aquatic plants, in the rivers and the lakes. So after work in all these those parameters and to see the critical situation, we decided to work in some remediation possibilities. We decided to work in bioremediation and phytoremediation. For phytoremediation, we use 3 species for the area because we need to have some cheaper solution, because it's a poorest region, so they cannot expend money in some treatment plants. So we decided to work with totora, with paja brava, and some algae. And in bioremediation, we were working together with the biotechnology department, and we used some kind of sulfate-reduced bacteria. And we found at the moment interesting results with the bacteria. We found a reduction of 20% of lead and between 82 to 90% of iron, and a similar percentage with the copper. And in the phytoremediation, we found the best result with microalgae for lead and copper. With the other plants, we found very bad results. So about the conclusions, in the area, the Bobo region has a strong anthropogenic and natural contamination. So there is strong evidence suggesting that the mining activities are responsible for the acid drainage and the high concentration of heavy metals in the north and northeast of the basin. Another important thing that we are working at the moment is the arsenic. The arsenic is related in the entire basin, is related for the mining activities and for the dissolution of the geogenic arsenic from the rocks. Lead, iron, and zinc comes mainly for the mining activities. Also, the rain is important because leach great quantities of material and transport contaminants to the Popo Lake, and there is a dissolution effect in water of some elements, mainly lead and some salts. The natural contamination was also observed in the south of the lake for the presence of a big amount of arsenic in groundwater, and the evaporation in the dry season caused large concentration of some contaminants. Also, the region has an interaction between the sediments, plants, groundwater, and surface water. For example, the increase of the contaminants by aquatic plants during the rainy season. And in this season is an increasing of the sediment load in the rivers, which cause a consequent dissolution. Also, the change in solubility were observed due to the pH changes. In the remediation experiments, the macroalgae and bacteria got the best results for reduce the concentrations of metals in waters. Now we need to start to make some more experiments about it, and we are trying to make some experiment planned in the region, not only in the laboratory. So thank you very much for your attention. If you have some questions. First.
Did you try rice or bioluminescence?
Rice? No, we didn't try. We tried paja brava, totora, that is a plant that grows easily in that region, and macroalgae. And now we are doing some experiment with some kinds of inorganic materials, but we didn't try rice. The next.
Interesting. I have one question. What is the public opinion for mining activity?
Yeah, the public opinion is that the mining activity is affecting a lot of the environment. We did some workshops with the local people, and also we had workshops with the governmental sectors. And in any workshop was present the people working in the mining companies. They were invited, of course, but they never were at the workshop. But the general opinion of the people is that they are affecting a lot of the environment, and most of the people is not taking care with the environment.
Does the government in Bolivia do something to protect population?
Yeah. After some years, when we got the first results, we started in 2001, as I showed you. So in 2004, the parliament started to see the situation and started to put more attention. Now they are controlling more, and the Minister of Environment is more focused than before in this region. But of course, the environment, as you see, is critical, is almost completely degraded. So we need to have a strong political for improve the environmental conditions in the region. More questions? Okay.
If we travel to Bolivia, Bolivia is safety?
Yeah, if you go to Bolivia, in general is not you will don't have problems, but of course some regions are dangerous. I think as many cities around the world, some regions are more safe and some of the regions are more dangerous. So the first thing is to talk with the people that knows very well the country, and don't visit the dangerous places, and don't go to the dangerous places. But it's safe. And also, if you are interested in visit Bolivia, of course you can go and you will be very welcome. I didn't put my email address there, but I can give you my card, and you can contact me if you want more information about different topics of Bolivia. Scientific topics, information about the university, and also some general questions.
How long does it take to the Bolivia project?
So, so far, for come to Japan, first I went to Miami. It takes 6 hours. So from Miami to Chicago takes around 3 hours. And from Chicago to Tokyo is around 14 hours. So that's the short way. Because for other way is when you come by Europe, but it is longer. It's around 30 hours. We are so far.
It is 1 day inside the plane.
Yes.
So maybe 2 days, 3 days of travel.
Yeah, waiting at the airport many hours.
Is the position level of opponent?
Sorry?
Is the position level or degree of opponent?
The pollution.
Position? Degree level or is decreasing or
Yeah, no, the problem in this region is increasing the heavy metal concentration. Because the last years the prices of the metals were increasing, so the mining activity is increasing as well, and most of the people start again to extract the minerals with any environmental control. So the contamination is increasing, and some places where before were not affected now are affected by the heavy metal concentrations.
is there a Chinese company to find out the resources at the mining region? I heard the Chinese company increasing the mining region in Africa.
In Africa,
Yes.
the Chinese company.
Yes.
Maybe I don't know about it.
Okay.
Yeah.
All these minings are of the Bolivian people or
No.
other countries?
Most of the cooperatives are Bolivians, but the big mines are people from United States and also from Japan. One big mine is also some capital from Japan, but most of the people working in the companies are from United States. So, other question?
Is medical treatment substantial?
Is
Medical treatment.
medical treatment. Yeah, that's one important point. We were trying to contact some people working in toxicology because our results, knowing the heavy metal concentration or knowing the critical environmental situation in Bolivia is not enough for start to make some solutions. So very few people, very few medical people is working in this area. We found just a French doctor that was working with us for a project, a short project, but he had to go again to France, so no one is working in this area. So we really need to complement our work with the toxicology issues.
Does the university team make also science workshop or science experiments, but also social experiments? For example, the kids and education, how is it related to people working in the lab?
Yeah, yes. For the projects, when we got a project, we got money for work in this kind of project. We need to have a social component. So we need to have a workshop, we need to have an interaction with the people. We need to explain to the local people what we are going to do, and we need to inform to the people frequently what we found and what's the next step, things like that. And of course, give to the people the results. No more questions?
Did you measure the head metals in the food?
Yeah. Yes, but it was an experiment for a thesis, for a licentiate thesis. The experiment was made close to Oruro. We analyzed heavy metals in some food as potatoes, carrots, and some cereals. And the concentrations are high in most of the food. But of course we need to do more experiments about it. Okay, no more questions? Okay, thank you very much for your attention.